Hi guys, how are you? Uh, okay, so last session as I remember, we were playing around with the LWJGL library, and we we were successfully calling a bunch of functions on top of the Skia, which is the uh, library developed by and maintained by Google, which is for 2D graphics, which is on top of the OpenGL and makes things a lot of easier and translates our graphical orders to the GPU. And for example, we were able to call draw image and draw string on top of the canvas, and the canvas did all the things necessary to load the bytes of the image and paint it to the canvas. So let me run it. So we have a canvas that we can draw image on top of that. We can draw a string. We can draw lines, dots, shapes, anything. And it's actually ready for us to do anything that we want. We can write a video game now. Actually, we have everything that we want. There is no framework here on top of the canvas itself, but we can build one to create video games, or we can create applications, desktop applications, mobile applications, which can run on any device. Because again, we don't have any framework yet here, but all the frameworks are using this Skia canvas. All the frameworks that you know out there are using almost this. And so this session, we want to put our functions and our knowledge to work, and we want to drive this application toward some kind of a framework, a desktop application framework. But first, we want to create a paint application, which we want to draw lines and shapes with dragging the mouse on our canvas. So before doing that, we have to, we can do this here, right here in the while loop, which is the place that all the drawings are being actually placed on the canvas before being flashed to the window and being shown on the screen. We can do everything here, but the project actually is getting messier. It's messy now, it's almost 200-300 lines of code, and if we want to move forward, we have to do a little bit of cleaning, and we have to extract some classes. So what we have here is a bunch of functions for controlling the window, building a window before we can draw on top of that. And here we are actually positioning. We are setting the position of the window on the screen. Actually, we are getting the width and height of the screen and the width and height of the window, and we are positioning and placing the window in the center, which when I run it, you can see that it's exactly in the center of the window. Here actually a bunch of OpenGL functions that I don't know what they are doing, and it's not necessary actually. And this is the last bit here, that we are creating a surface for Skia on top of the OpenGL, and this is the main place of the application, and we want to have some kind of a callback here that will call us back and will pass us the canvas to draw anything that we want. Okay, so let me just create a class here. I want to create a class which is we have named our framework UI. This one will be UI window. Here we can see that we are actually, the window has height and width, has X and Y for positioning, and let's add them here. So it has let's make it public or private, I don't know. No, let's make it private. Width which is an integer. And sorry. It's 0. Let's make it 0 or private var. I've forgotten the var. Yep. Private var hide, which is again an integer. Then x and y. Then we can see that we need setters and getters, which now because these are properties, these have setters and getters, we can override their setters to actually to change the width and height and x and y. Let's make it an interface, not a class. Not a class, and we don't need these. Okay. Then we have this visibility. Yes, we can specify that we want to set the visibility is visible. Now let's make it visible, which is Boolean. And then and also let's implement this class, this window, UI window LWJGL implementation. So we want to abstract away the window, because the window has a bunch of properties and functions, methods, and it has nothing to do with the implementation. We can implement it with something else, but now we want to implement it with Skia and LWJGL. So we are actually building our own framework here on top of these lower level libraries. So UI window, each window can have width, height, x, y, and visibility, but here we are going to implement it with okay, I added them here. Let's bring all of them here because we want to add functions. Okay. So now, for example, for setting the width and height, let's give, for example, 300. Let's override the setter. When someone actually sets the width and changes the width, we want to tell the LWJGL window to change the width. So here we can see that I think we have the function for changing, but let's first change the position, because for changing the position we have this function get window size and set window position. This is the one. Okay, so we copy this, we bring it here for the, let's give, okay, and we want to, this window is a long number, is a number of type long, is an indicator actually to the OpenGL library, the C++ library, that we are talking to this window that you have created, the buffers, and this is in detail in the implementation, and this is not necessarily important, nothing important here. So let's say we have this private var window handler, which is, for example, 0 at the beginning, and we pass it here window handler, and for x we will pass the value, and for y we will get the y itself. And let's make it a long. Okay, so, and after that we want to set the value to the field. We have overridden the setter of the X, because beside changing the value of the backing field, we want to also set the, actually, we want to tell the OpenGL framework to change the X position. Okay, now for the Y, it is the same. I copy and paste it here for Y. And we want to call the X, but we want to give the value to here and change the value as well. Okay, these two are done now. We can get back here. Okay, we don't want this, because also this one is for asking the width and height of the screen. So maybe it is useful sometimes to ask the width and height of the screen. Let's add it here. Screen width, which is int, and screen height. Okay, and let's get this one and cut it here, and we'll figure it out later. Let's implement the screen width and height. Okay, we cannot set it. It should be val. Sorry for making it var. It should be a val, because the screen width and height, we can only just get them, ask for them. That's obvious. So we should also make them val here. And okay, so for calculating the screen width, we actually, I've forgotten the stack. Okay, what is a stack? We have to ask this one for the primary window. It will give us this p width, p height. Okay, we don't want that stack. These are unnecessary. So we give the window. Now this one is for getting the size of the window. And here again, we give the window handler. Okay, we need this width and height. We just need this to return them, nothing else. Return window width, and let's also add it here. Return height. Okay, so now we have two functions inside this implementation class, which asks for the window, or no, not the window, the screen, the monitor, width and height. Also, we have here, we can ask for the size of the window, and we can set it as well. So we have not implemented this part yet. So we have get window size. I suspect that we have set window size as well. Set windows size. Yeah, yes, we have set window size. So we can bring it there. Here we can call set window size, and we give the window handler and the width and the height. So the width will be the value, the new value, and we pass the height as is. And again, we change the field. Also for the height, we do the same. So for width, we pass the width as is, but for the height, we pass the new height, and we save the value to the backing field of height. Okay, so now we have implemented the width, height, x, y, screen width, screen height. We can get rid of this part here. And for the visibility, for making it visible, we have window will reside, the window will stay hidden. I think we had one here. We had some function for that. We can get back to that later. Okay. So what do we have inside a window? So inside a window, we have some kind of loop that we want some kind of a callback, some kind of a mechanism to actually let us hook or get the chance to draw our stuff on top of the canvas. So we need some kind of callback. I want to add a callback here. We want to say that, okay, the window should have some kind of, for example, draw content callback, that this callback, we can pass some kind of an interface, a function that will call us back, and it will pass us the canvas so that we can draw our stuff on top of that. So this UI window is an interface of our own framework, and we want to have also a UI canvas, another interface. Again, this interface will be a part of our own framework, and it will be implemented by the LWJGL and the OpenGL and Skia and other lower level libraries. But we don't want to pollute our frameworks. All other frameworks that you know out there are pretty much the same. For example, Android, you don't see calling functions on top of the OpenGL. They are all hidden and abstracted away by the framework, and we are doing the same here. So we have the UI window. This UI window we want to ask for a callback that will pass us the canvas, and also will, for example, return nothing. Okay. Here, if we want to implement this one, actually, for implementing, there's nothing to set. We just set it with an empty callback. If the user of this framework does not pass any callback to us, we will just call an empty callback during the drawing phases. So now it's the time for creating the window inside there, and we want to transfer and move all these nonsense which is just for creating the window, and we want to hide it inside the implementation. So let's add a static function. Adding a static function here will be inside the Kotlin. We should add it in the companion object. So inside the companion object, we add a function for creating new window, let's say. And this function will return a UI window, and it will instantiate an implementation of this window and will pass it to the user. So this is some kind of a factory method here, which is hiding the real implementation of the instance that we are passing. So before creating this window, we have to do all these nonsense. We have to call the init, which will do all these stuff. Let's move it there. Let's move this init there, inside here. And also for the looping, I think we should add this loop to the window itself. Let's move this one there as well. Okay. Actually, I know that this might not make any sense at the moment, because we have done nothing actually in this video till this moment. But just bear with me, just stay with me. At the end of this session, you will see a clean framework, which is our own framework, and we can talk to this framework, and our framework will talk to the OpenGL and will talk to the Skia and lower level libraries underneath it, and it will hide us all that complexity. We are hiding this complexity of creating a window and talking to this window, drawing stuff behind our own framework. Okay, so for creating a window, we need first we call this window, we pass the width and height. Let's ask for the width and height. Width, height and then this creates the window. The window has title as well. Okay, let's bring it here, and this will be width, this will be height, and this is a long, which is window handler. Okay, we have created a window here, but before that we should call these as well. So let me, actually I forgot, I cut it and pasted from right here. Okay, actually let's change this one to like this. We pass width and height here, we make it width, height, and this will be the window. Let's rename it to window handler. Okay, good. And at the last line we just return the window handler, which is a long, not an integer. We change the type to the long. After the initiation, we just want to create capabilities, call context, and all these stuff, which is not that important to us. Okay, so let's add this init function here, private fun, the loop function. We are adding the loop function inside our implementation class, and so we cut and paste all this stuff there. Okay, so let's get rid of this function. We add it here, and inside here we have access to the width and height, and also the window handler. Okay. So what we have to do here is to var window equals UI window LWJGL implementation and return it. Return the window. But before that, we call the init and we pass the width and height. Let's call it here. And after that, we call the loop function of the window, actually to kick it start, the drawing loop. So also we have to pass the handler to the window. So here we have this function, we add it to the constructor. So a type of, okay, let's give the type. Done. So width, height, xy, screen width, height. We'll get back to this visible. We have this draw content. So after this loop kicks in, inside this loop, actually we don't want to every time draw this image and a string. We want to inject and hook we want to inject our drawing here. We want to have some kind of a hook, some kind of a callback that will give that this window will call us back at the right time when the drawing is being issued actually. So let's get rid of these two and also this one. So here we have this callback, if you remember, draw content callback. We want to call this callback, and also we have to pass the canvas implementation. So inside the canvas, we have functions like, for example, drawing lines, for example. Or we have functions like draw text. And for example, for drawing lines, we want a list of points on the screen. Actually, we are shaping our dream here, our own framework. We are creating our own framework with the interfaces of our own, and then we are trying to implement these interfaces with some kind of real implementation and we are hiding the implementation details behind our own framework. So for passing points, let's create another class and name it UI point. Obviously, a UI point should have an X and also a Y. So inside the canvas, our dream is to pass a list of UI points, and the canvas should somehow magically draw our lines on the canvas implementation. For the text itself, actually we have to pass the text and also, for example, some kind of an anchor point, which is a UI point. Okay, so we have these two functions, for example, and here we need because this is an interface, we need an implementation of that interface. So again, we try to implement the UI canvas with the Skia. Okay, let's implement the UI canvas and implement the two functions. And we can create the canvas somewhere here. We have this canvas, the surface canvas. Okay, so here we should save this canvas. Okay, so let's let's create a property here in the UI window for saving the canvas, storing it after creation. Here we are creating a canvas, and this is the canvas of the Skia framework itself. And so we want this canvas to be stored. Sorry, I should put the type after, because I'm switching in my daily job to the Java and other languages like Dart, and I just get stuck inside the languages. Okay, UI canvas, this should be a late init. Here we can say canvas equals UI canvas Skia implementation, and we can pass the Skia canvas to that. Okay. And we are done here. We don't need this paint. We need actually our own paint. If you remember, this paint is that brush paint that we are setting the font size and the color, the width of the lines and other stuff. And we need some kind of our own paint as well. So we write the UI paint. I made it, I think, the Java class, or no, it's Kotlin class. Okay. So this is a UI paint. Here we can get rid of these and also these as well. Clear color, we don't want this. Okay, let's comment out these lines. So this loop is doing all the necessary stuff now to create a Skia canvas, and we are hiding again this Skia canvas behind our own canvas. Or you might ask here, what is the necessity of doing all these actually all this hiding and seeking stuff? We don't want to pollute. When we create a framework or our own library, we will at some point call other libraries and frameworks, and we don't want to actually let the user of our framework to be aware of the underlying implementation, so that we can change it later. Maybe later we change the implementation of the UI canvas and UI window with some other library or framework. Okay. So here inside the canvas, we pass the canvas inside this callback. We call back this guy that is trying to draw stuff, and we pass the canvas. Okay. This part is done as well, and it's all right, I think. For the visibility, this one is not working. So at first it is visible, but when it is set, we want to, I think inside this GLFW, we should have some kind of visible or something like that. I've forgotten. Let me check it here. So when we are creating, we are this is the one. This is the one for hiding and showing the window. So we pass false or true for making the screen visible or invisible. So if visible, if value, then true, else false. Okay. And also we save the value to the field. Okay, so now we have all the implementation stuff hidden behind our own interface. So it's time to put it to the test. So instead of this draw content circle and draw text, let's get rid of all these. Draw polygons, draw lines, and all this stuff. We don't need this. And also not the point. And also these init and loop. Let's get rid of this one. These. And also this. These are being done for freeing callbacks. Okay, at the end we have to clean up the window. So let's add another function here for cleaning up. Fun clean up. And we cut and paste these lines to the cleanup and we implement it here. So okay, this is how we clean up the window. We pass the window handler and it is terminating. We don't have to worry about these things. I just copy and cut and paste it here. I just know that these 4 lines are for cleaning up the window created by the OpenGL, the LWJGL library. We don't need this anymore and all this stuff. And here we just can say, okay, I want a window. I'm asking the UI window implementation for that. And I can say 500 by 500. Then I pass the callback. So here you can say that, you can see that I'm just talking to the graphic with my own framework. I hit all Skia, LWJGL, OpenGL, everything behind my own framework here. Simply, I am just saying, okay, I need a window which has a width and height 500 by 500, and then I want to plug into the drawing sequence, drawing phase of the window, and I want the canvas to be passed to me so that I can draw my stuff on top of that. For example, I can say it let's draw lines, or I don't know, let's draw lines. Okay, list of UI point 0, 0, another point to 10 and 100. Let's make it val. It doesn't need to be a var. Okay, you can see that in the imports we don't have any of the imports of the underlying frameworks. We just have our own framework classes and interfaces. If I call it now, I think we have some kind of a problem in the canvas implement. Yes, the canvas we have not implemented yet, and also we have some problem somewhere. I don't know. Okay, let's tackle this one, the draw lines. So for drawing lines, private val, we call the draw lines function of the Skia canvas. So we can call this one for each 2 consecutive points inside this, and also we can call this one. This will draw points using clip matrix and paint. Each pair of points have draw a line segment. One line is drawn for every 2 points. Each point is used once. If count is odd, the final point is ignored. Draw lines. Maybe this one. Maybe we can do this one or this one. Let's call this one to see what will happen. So for this, we have to pass the coordinations, and which is a float array. So let's map the points to the float array dot array of, I don't know the functions, float array of, yes, this is the one, float array of it dot x, it dot y, and then we can change it to a typed array. Okay, this has to be float. We convert our ints to the float, and also the draw line needs paint. So paint was the brushing paint. Also, we have our own paint here, and we can ask for the paint in the draw lines function. So here we will ask for the paint as well, which is a UI paint. Also here, UI paint. Okay, and in the implementation, we have to add the paint here. Okay, and now I can create a paint. Let's create the paint, because creating a paint of canvas Skia is a pricey action, and we have to save it, cache it to make the drawing faster. So private paint equals, sorry, this should be a var paint of the Skija. Okay, here I load the paint with the stuff. For example, I change the, let's call it P. For example, I set the color of this paint with the color inside our own interface paint, the class, which is not necessary now. So let's just simply pass the P, and this should work, but it is not, because it needs an array, float array. Float array. Let's see what we can do here. Let's create a for each. Let's say iterate from 0 to what? To points dot last index, but not the last index, -1 for each. We will say we want to call the draw line function for each 2 consecutive points. So let's say draw line, and I think this one is easier. x0, so it will be val p1 will be the points it, and also p2 will be the it plus 1. Yep. So now we can say p1.x at the float, p1.y, p2x, and p2y. And then we pass the point, and it is done. Okay, so we hit the implementation of drawing a bunch of consecutive lines via the Skia behind our own canvas. Now I think if we call it, let's run the application to see what will happen. Okay, let's run it. We have an extra parentheses here. Oh, we need a paint. We need a paint here. Let's create a paint var paint equals UI paint. And we pass the paint. Okay, now we run the application. The screen is black. I think because we have not set the color. So let's set the color. Let's say we need to set the color in the paint. So we can say paint.color equals, for example, this can be an integer. Let me see how we are setting the color in the Skia. So in the UI canvas implementation, here we can say p.color. We have, we can pass an integer, which is ARGB. This one is good. Okay, so let's say color is 0x FF 2, 3, 4, 1, 5, 6. And let's create the property inside the UI paint var UI, no, sorry, the color, which is an integer. And here we have to call to int. Let's move it here and give it, for example, 0. Okay, so now we are passing the paint, our own paint, which is loaded with this color. This is an ARGB code, and in the Skia canvas we have to set it to the UI paint, to the paint that the Skia can understand. So we will say paint.color. Now let's run it to see what will happen. Again, we don't see anything. The screen is black. Oh, and I don't know why. Let's see. Let's check it. So here we have commented out these lines. 0F00 font. I think we had a line here that was setting the clear color. Let me see. We had this function, clear color. Okay, let's bring it there. Maybe this will help us this time. Oh, sorry. This is the one here. We are calling GL. Let's run it. Yep, we get that red screen, but the lines are not being drawn. Lines are not being drawn. Why? The callback is being called. We have set the callback here. We are calling draw line. Let's have a print line here to see if it is being called. No, it's not looping. Actually, the loop is not working. So let's see why. Inside the implementation, after creating the window, we are calling the loop of the window. So inside the loop should close. It should be called at least one time, but it's not. Let's add a print here to see if it is being called or not. Inside loop. Okay, the loop is being called. Actually, the loop is being called, is working, and it is calling our callback. It is calling our callback, and we have changed that callback But what's the problem here? What is the problem here? I don't see any problem actually at all. Everything seems fine. GLFW show window, clear color. This is the one. The canvas is laid in it. The width, the height. Oh, I see. When the loop starts, actually you can see that when this loop starts, because our application is a single threaded application and it's not being run on another thread, this will block here, this will just be here, running here, and the application will not pass this line and it will not call line 10. It will call create window, inside the create window will call loop, and here it will stuck here forever. So we have to have a thread here, create a new thread and run the loop inside the new thread. So we can say thread, we are opening a thread and calling the loop inside that, and then we are returning the window. Let's see. Okay, OpenGL context current and current thread. So I need to create this loop, I think this thread here before calling the loop. And so inside the init, we have to create the new thread, because the OpenGL will work only on the current thread that was initialized on top of that, and we are initializing the OpenGL in the main thread. And we have some threading issues here. Let's see where we can plug. We can create the thread here, but again, because we are talking to the OpenGL with these functions, again, we will have exceptions. So here again, we have to create the thread. And let's move the init inside the class itself. We are moving the init here. And we will call the init and then the loop. So we pass the width and height. So let's get width and height and pass width and height here. And for creating a window, we don't need to have this here. Okay, so after everything is done, we will have an init function which will call the init width and height. We don't need this width and height anymore because we are inside the class and we have access to that. And loop. Okay, so now we can create a thread here and do all this stuff inside the thread. Let's run it to see what will happen. And we have null pointer exception inside the loop. The window handler is null. no, it's not null. Let's get it outside of the thread, see if it works. We have again null pointer exception, glfw. We're calling the init function. It's doing everything. Oh, maybe. Yeah, we are setting it width and height here. Before, let's say if what we can do, because we are setting the width here, we are calling this function before the window handler being initialized. So what we can do is we can give a 0 at the beginning, or if window handler not equals 0, something like that. And also here, let's call it loop init. Inside the loop, we are going to glfw should close. Inside the should close, it is checking the window, and the pointer is null. So what is the pointer? Pointer is the window. Okay. It's because that inside the init, we should save the window handler. That's the one. Okay. Yeah. Now we have our screen back. Let's run those two functions inside the loop, inside the thread, sorry. So we create a new thread and we call these two functions inside that. And we have our callback is working. You can see these high are being printed, you know. It is being called, the loop is looping, that drawing loop, and it's calling our callback, and it's giving a chance here. It is giving a chance here to us that in each frame we can draw our stuff on top of that. So for drawing a painting application, for creating a painting application, we need to store, actually access and store the position of the mouse cursor and save it somewhere. For example, we can say points equals mutable list of UI point, and we want to ask the window, because this is the capability of the window itself. We want to ask the window to call us back when the user clicks on the window. So again, in the UI window, we should have this press callback, and the press callback should pass the UI point, which is UI point, and should ask for nothing to be returned. Here again, we have to override that with an empty implementation, and then we will call back the press callback when the user presses on the screen. So in the init, let's initialize the call. Okay, so I just copied and pasted this line here, this bunch of code, just for setting a callback to the mouse clicks, and then asking for the current position of the cursor, and extracting the X and Y, and then calling back the press callback. This is not necessary, stuff. You don't need to actually get to know everything, every detail. We just want to translate this functionality from the underlying implementation to our own framework. So now if I run application, you can see that if I click here, for example, this is the bottom left, which is 0 and 0. This is the top right, which is 500 by 500. you can see that it is working. But for every click, we have two events. One is for the click, and one is for the press, and one is for the release. So here, when the user presses, we want to save the point to the points. So we add the point to our points, and then here for drawing lines, we give all the points, we pass all the points to the draw lines. Now if I run it, it's not working properly. Why is that? Maybe it's because, let's see, we have this height minus. I think this is wrong. Okay, you can see with clicking, it's working, but we want to drag the mouse and we want it to work. It's not working now like that. So set mouse button click, maybe we have set mouse drag, or set some kind of a callback like that. Mouse callback, set motion, or no, for mouse we only have button callbacks, which is called when mouse is pressed or released. Okay, I don't see the callback for moving, but you get the idea that actually we have a Paint application now written with our own framework. This is our own framework with 10 lines of code. We have created a window 500 by 500, and we have set the painting brush color, and we have given a press callback and a draw content callback. So the press callback, we are hooking our stuff to the framework, and that is translating this to the OpenGL and Skia and LWJGL. Actually, we are trying to implement a safe and how can I say, a simple interface for drawing and for making complicated frameworks. For example, for creating Android on top of this. It's some kind of Android, our own framework. And in the next sessions, we will go toward creating some kind of a fully fledged UI framework for example, laying out our elements, the text fields, the images, the buttons, and all those elements in UI widgets. But you see that it's working. We have actually abstracted away everything behind our own interfaces, our own classes. I know this session was actually complicated and messy, but we will somehow, I think maybe this is the last session that will be messy and annoying. From next session, we will see that we will use our own framework for building better stuff, because now we have hidden all that complicated, ugly underlying frameworks. I hope you learned something, and thank you for watching. Bye.